Let's look at question 17. Again, find the real solutions, if any, of the following equation. Use the quadratic formula. Again, to use the quadratic formula, our equation's got to be in the form of ax squared plus bx plus c is equal to 0. So the first thing is our equation's got to be set equal to 0. Again, the reason this is a quadratic equation is the highest degree is a power of 2. So degree 2 equations are called quadratic. And degree 2s can have up to 2 solutions. They can't have more than 2 solutions. So to solve for x, using the quadratic formula, we have to take the opposite of b plus or minus the square root of, then we have this b squared minus 4 times a times c divided by 2 times a, or 2a. So if we're looking at our equation, we have this 6x squared. Notice that this 2's got to come over, and this negative 2x has got to come over. So remember, when they come over to their side, basically all that has to happen is the signs change. So this negative 2x is going to become a positive 2x, and this 2 is going to become a minus 2, and this is now going to be equal to 0, since both of these pieces moved over to the other side. That now creates 0 on the right-hand side of the equation. So then we can identify our a as a 6, our b as a 2, and our c as a negative 2. So using the quadratic formula, we first have to take the opposite of b. So the opposite of b is going to be a negative 2 plus or minus the square root of. So we have this b squared. So 2 squared, which is actually 4, minus then 4 times a, which is 6, times c, which is negative 2. And then we're going to divide all that by 2 times a. So 2 times 6 would be 12. So the catch is doing what's inside the radical, the square root symbol. So we have this 4 minus then 4 times 6 times negative 2. And we end up with 52. So x equals then this negative 2 plus or minus the square root of 52 all over 12. Now, the thing is we have to simplify what's inside the radical. So remember, we're looking for what we call perfect squares. So if we can find some factor pairs, then those factor pairs come out as a single factor. So over here, we'll make our little t-chart. And the 52 will go on the top. So remember, I like to use the prime numbers are this 2, 3, 5, 7, 11, and sometimes 13. So we're going to start with, since 52 is even, we're going to divide a 2 out. So half of 52, that's not as easy. It's 26, I believe. So 2 goes into 22. I'm sorry, 2 goes into 52 26 times. And notice how 26 is also factorable. I can also take a 2 out of it. So I'm going to divide 26 by 2. So if I divide that by 2, we end up with this 13. 2 goes into 26 13 times. Notice that 13 is a prime number, so 13 is going to go into 13 one time. So this left-hand side is what we're looking at. This is our prime factorization. What we're looking for are factor pairs. And also that there's a pair of 2s. So that means I can bring 1, 2 out. That means the only thing left inside the radical will be the 13. So we have this x equals then the negative 2 plus or minus. So a 2 is going to come out and leave me a 13 inside there. And then this is going to be all over 12. So to simplify this, it's a good idea to kind of just separate this as 2 separate pieces. So the negative 2 over the 12 plus or minus the 2 square 13 over the 12. And notice that the 2 and the 12 have a common divisors of 2. So that actually reduces down to a negative 1/6. And plus or minus. Notice how the 2's here will divide out. And that will leave me the square 13 on the top and a 6 on the bottom. So that becomes our solution set. So if we want to write it as 2 solutions, we write this as negative 1/6 plus the square 13 over 6, comma, and then negative 1/6 minus the square 13 over 6. So that would be a way to write it in exact form. You also could just write it as negative 1/6 plus or minus the square 13 over 6. Or if you want, you can actually leave this as negative 1 plus or minus the square 13 over 6. That would be a third way you could also write it. If you want to put it back together as one fraction, you could. So that would be the solutions for question 17.